This is question 13 from the May 2016 IB examinations. Take a moment, give it a try, and then hit play. So this is talking about taking some NaOH and reacting it with HCl. And hopefully right off the bat, that's a trigger for you when you have hydrochloric acid, so an acid plus a base, particularly one that contains either an oxide or a hydroxide. You have a neutralization reaction. And that's one of our reactions that we should know is always going to be exothermic. So it's going to be releasing energy. So hopefully you remember that. And we hopefully also remember that that acid plus base is going to form an ionic salt plus water. So in this example, we have NaOH reacting with HCl to form H2O, and the leftover salts, Na is an oxidation number of +1, chlorine is an oxidation number of -1, and so it's a 1-to-1 relationship, just NaCl, regular old table salt as the product. Since this reaction is exothermic, we can look right away at our possible answers to make sure that they are negative. And unfortunately for us, all of these are negative, which means we can't rule any of them out right away. So we can't use that as a trick. The rest of the problem is asking us to look at enthalpy, specifically the enthalpy of neutralization. So in general, anytime I'm thinking of enthalpy, I'm thinking of heat. I'm going to use the equation Q is equal to mc delta T as the basis for anything that I'm thinking about when dealing with this type of problem. This would end up giving us an equation or a value that was in kilojoules. However, it's very specifically telling us that we need kilojoules per mole. So we're going to look at the number of moles of solution as well. So thinking back to this equation, Q is heat, and that's kilojoules. We've got M for mass. C is the specific heat capacity. And then delta T is the change in temperature. And we've got all of the information that we're going to need above. We know that the mass is going to be related to the fact that the density is 1 gram per centimeter cubed, and my total mass, or my total volume, let's start there. My total volume is from the 25 centimeters cubed plus the 25 centimeters cubed of this. So that's a total of 50 centimeters cubed. But if we have a density of those being 1 gram per centimeter cubed, really it's a 1-to-1 ratio with grams. So we have 50 grams of solution. And that's going to go into our M value here. The C is given to us as well at 4.18, and we want it in kilojoules, so I'm going to use this one to make my life a little bit easier along the way. Kilojoules per kilogram Kelvin, but I do notice this thing here, grams and kilograms are not the same thing, so my 50 is going to have to be divided by 1,000 to get to kilograms. So we're going to have that for our mass, that for our C. The delta T, it doesn't tell us what our temperature actually is. It's trying to make it easier on us. So it's going to say we're going to leave that as delta T, which we see here in each of these. They've left it as delta T. And that's going to give me the kilojoules. And again, I'm going to have to take one more step to get it divided by moles. So let me plug in some of these numbers and see if they start making sense with any of these. We've got the 50 centimeters cubed divided by 1,000 centimeters cubed. But we already changed those, so we changed it to grams. Oops. Here we go. So we've got grams per kilogram, and that's going to be multiplied by my 4.18 kilojoules per kilogram Kelvin, times my change in temperature, which we can assume is in kelvins. And we can start looking at some of these units to see what's going to cancel out. Kelvins would cancel out, kilograms would cancel out, those grams would cancel out, be left with kilojoules. So far I can start looking at my possible answers. I don't want a 25 up here, so neither of those are the correct answer for me, so I'm left to 2 more. And so all I have to do now is figure out how many moles that I have from my either HCl or NaOH. So I'm going to look at that number there. I've got 25 centimeters cubed, but that's not going to cancel out exactly with my 0.1 mole per decimeter cubed because I need this in decimeters cubed. So there's 1,000 centimeters cubed in 1 decimeter cubed. I'm going to multiply that by my 0.100 moles per decimeter cubed. So you see that the centimeters cubed cancel out, decimeters cubed cancel out, and I'm going to be left with moles. So this is my denominator here. And let's clean this up a little bit because it's gotten quite messy. Use a new color. So we've got 50 divided by 1,000 times 4.18 times delta T. And here we've got, let's move this down a little bit. We're going to be dividing by the moles that we've calculated. So 25 divided by 1,000 times 0.100. And we can see that the thousands would cancel out, and so we would be left with 50 times 4.18 times delta T divided by 25 times 0.100. We see that D is the correct answer.